So I thought this would be a good way to review, and we'll spend a whole day reviewing dimensional analysis as well. Okay, so let's get started. So remember, when we're talking about dimensional analysis, what we're doing is we're showing how different units of measurements are equal to each other. All right, so let's do a real quick and easy example. I've got 120 donuts and I want 120 dozen, and I want to know how many donuts that equals, right? So let's set this up. So I have 120 dozen. Let's just do DOZ for dozen, all right? And then I just want to do my equality. I need to show in a dozen how many donuts are there. So in 1 dozen, there are 12 donuts, all right? So and I want to set this up so that my starting unit can get canceled out, okay? And then since I have a 1 on the bottom, I just multiply 120 times 4, and I get 1,440, okay? Easy, right? The only problem is I've got 2 sig figs in my original number. I got 3 sig figs in this number, so I need to work this out to where I only have 2 sig figs, so I can do one of two things. I can either round, or I can use scientific notation. In this case, you kind of have to do both. So I can round this to 1,400, or I can use scientific notation, which is probably a better thing to do, or I can do let me erase that, sorry, or I can do I messed myself up here. So, or I can do 1.4 times 10 to the 1, 2, 3, so I have times 10 to the third. And of course, donuts would be my unit of measurement here, okay? Very quick and easy. Let's do one that might be a little bit more difficult. I've got 12.9 megagrams. Remember, this capital M is for mega, and I want to change that into nanograms. So let's set this up, 12.9 megagrams, okay? And again, we're just showing how different units are equal to each other. And so in 1 megagram, there are 1,000 kilograms. And then we're just going to keep going down the line here. In 1 kilogram, there are 1,000 grams. And in 1 gram, there are 1,000 milligrams. And in 1 milligram, there are 1,000 micrograms. Now that's the little weird symbol for micro. And in 1 microgram, there are 1,000 nanograms. Okay, now that's a whole lot of zeros when we look at this, right? We've got 1, 2, 3, 4, 5 sets of 3 zeros. So now remember, what we can do to make this a little bit easier so we're not writing down 15 zeros, remember 1,000 is the same thing as 10 to the third, right? So each of these is 10 to the third, okay? So when we put this up, 3, 6, 9, 12, 15. So could that mean we could just say we do the same number, 12.9 times 10 to the 15th? Well, kind of we can do that. Remember, for scientific notation, you can only have one number in front of the decimal point. So we actually need to move this decimal one space over. So since we're doing that, now this 15 changes to a 16. So the real answer is 1.29 times 10 to the 16th, and then we're nanograms is our unit of measurement. So this is our actual answer here. Okay? Now, I want to leave a couple of these blank so you can practice some on your own. So let's skip over to another one here. So let's look at this one. We've got 2.29 times 10 to the 4th microliters. That's that little funky symbol there. And we want to know how many liters. All right, so now I know sometimes this scientific notation kind of scares you guys a little bit, but I'm going to show you how to deal with that. So when we set this up, we're going to go 2.29 times 10 to the 4th. All right, we're microliters. Okay, so we're going to go microliters, so we're going up to liters, so we've got to go up the steps. So remember, when we go up the steps, we're going to have our tens, hundreds, or thousands on the bottom rather than on the top, what we just saw. All right, so we have microliter. Remember, there's 1,000 microliters in 1 milliliter, and we're going to keep going up the steps. There are 1,000 milliliters in 1 liter. All right, remember we set this up so we can cancel out our units. So we're left with liters. That's what we want. Okay, now we've got these 1,000s here, so we can do like what we just did with the last question. 1,000, the same thing as 10 to the third, right? But since we're on the bottom, we want to make these negative thirds. All right, so these are 10 to the negative. So what we have here is basically 10 to the negative 6 when we put these together. So a really easy way to do this is just realize that I've got 10 to the fourth here, and then I've got 10 to the negative 6th here, right? So 10 to the fourth plus 10 to the negative 6 gives me 10 to the negative 2nd, okay? Now, I could go through and I could move my decimals around and do all that stuff, but all I have to do is just look at this. If I started out with 10 to the fourth and I ended with 10 to the negative 6th, all right, that's going to give me 10 to the negative 2, so all I have to do is just keep the same number, 2.29, there's a point there, times 10 to the negative 2. That's going to be my answer, and our unit of measurement is liters. So there we have our answer, okay? So don't let this scientific notation stuff scare you. Just think about it and figure out how this is going to work out, especially in a situation like this where you've got these nice, easy numbers to work with. All right. Now, unfortunately, it's not always going to be that way, but when it is, it's very easy to do. Now, if you have a situation where it's not in a nice, easy numbers to work with, you can go ahead and move the decimal around, but just make sure that you're paying attention and be very careful about that. All right, let's move on to another one. I'm going to leave a couple more of these blank so you can have time to figure these out on your own. Let's look at the very last question, all right? Because we've got this centimeters cubed, and I know we had some problems with that last time. Okay, so let's just look at this. All right, so we've got Mildred measures the volume of a basketball to be 1.5 liters. How many centimeters cubed is this? Here's the key. Remember, 1 centimeter cubed is the same thing as 1 milliliter. Okay, so for us to figure this problem out, basically all we have to do is go from liters down to milliliters, and that's really easy. 1.5 liters, show my equality. In 1 liter, I have 1,000 milliliters. All right, so my liters cancel out. I'm at milliliters. Now all I have to do is just show how milliliters is equals to centimeters cubed. So if I got milliliters on the top, I have to have milliliter on the bottom. So that cancels out. I've got 1 centimeter cubed. All right, so here I'm left. That's all I have to do is just do centimeters cubed. And now, since I got 1s on the bottom, I just multiply across the top, right? So that's 1, 5, and then 3 zeros added onto that. Check my sig figs. I got 2 sig figs. I got 2 sig figs here, so I'm good. Centimeters cubed is my unit of measurement, and there's my answer. Easy breezy. All right? So make sure you spend some time working on this. Again, we'll do a whole day on Thursday. But don't let dimensional analysis scare you. Work with it, and you will be just fine. All right.